Hydrogen is found in the nebula, protostar, and main sequence stages of a star's life cycle. Helium begins the red giant phase. Carbon begins the nova phase. In the stage of a nebula is a cloud of gas mostly made up of hydrogen and dust in space. Nebula are the birthplaces of stars. There are different types of nebula. An emission nebula, such as Orion's Nebula, glows brightly because the gas in it is energized by the stars that have already formed within it. In a reflection nebula, starlight reflects on the grains of dust in a nebula. The nebula surrounding the Pleiades cluster is typical of a reflection nebula. Dark nebulas also exist. They are dense clouds of a molecular hydrogen which partially or completely absorb the light from stars behind them. In the protostar stage, it is when a large mass that forms by contraction out of the gas of a giant molecular cloud in the interstellar medium. The protostar phase is an early stage in the process of a star formation. The main sequence is the stage where a star spends most of its existence. It lasts around 10 to 11 billion years. In the main sequence, it is when continuous and distinctive bands of stars appears on plots of stellar colors versus brightness.
Predict that 5 billion years in the future, our sun will reach this critical crossroads. Its supply of hydrogen fuel will have been completely exhausted. Nuclear fusion will cease, and gravity will begin to crush the star. At that point, the situation is desperate. In order to survive, a sun-like star must find a new source of fuel. It has helium on hand, but in order to start burning helium, the core has to be 10 times hotter than it was during its lifetime burning hydrogen.
It won't be able to fuse that helium into heavier elements like carbon and oxygen until the core gets sufficiently hot. And that's because it's harder to get the helium nuclei close enough together for the strong nuclear force to take over, grab them, and cause them to fuse together.
As it continues to contract inward, nature throws the star a lifeline. The core actually becomes superheated by the very gravitational pressure that's trying to crush it. When it reaches 180 million degrees, it can start fusing helium into carbon in a desperate gamble to survive. The star, which took 10 billion years to burn through its hydrogen, now powers through its supply of helium in a mere 100 million years.
And then the action begins. It runs out of hydrogen, starts fusing helium. Runs out of helium, attempts to fuse carbon and will fail. But all the action, all the, well, what's going on now, happens in the last 10% of a star's life.
The searing heat of the helium burning actually causes the outer layers of the star to swell.
At that point, the outer atmosphere of our star will be held in by gravity so weakly that it'll start sort of just evaporating away. Through a series of what I call cosmic burps, it will actually eject the outer envelope of gases, which are only weakly held by gravity. That'll send some shells of gas outward, illuminated by the hot central star. And that will cause what's called the planetary nebula phenomenon. Beautiful shells of glowing gas surrounding the dying core of our sun.
With no nuclear reactions to generate outward pressure, gravity gains the upper hand. The star begins to fall in on itself. The contracting star finds its ledge in a surprising place: electrons, tiny negatively charged atomic particles.
Electrons don't like being compressed so that they're very close to one another, because electrons effectively don't like each other.
If you compact the electrons hard enough, the pressure of the electrons themselves is able to hold up the star against gravity.
When the core of our dying sun-like star is crushed to about the size of the Earth, this so-called electron degeneracy pressure takes over. Gravity can collapse the star no further. It's left to slowly cool into a bizarre stellar remnant known as a white dwarf.
Red giant is the dying stage of a star. There is no specific life cycle description for this stage, but it lasts between 1 and 2 billion years for the star to start to die out. In the stage of a white dwarf, this is a very small hot star. It's the last stage of a life cycle of a star. White dwarfs have a mass similar to that of the Sun, but only 1% of the diameter. White dwarfs are shrunken remains of normal stars, whose nuclear energy supplies have been used up. White dwarfs consist of degenerated matter with a very high density due to the gravitational effects.